This is a video about sculpting again, and this is in project finance, and it's about the issue of sculpting with fixed debt. Okay, now I realize, and I'm embarrassed to say this. I've got to switch things around. I have done this kind of incorrectly too many different times. And really, when we have a sculpting with fixed debt, I'm going to put over here, they're really methods. Now, let me just introduce the problem. So if we just did our normal sculpt, it's not normal sculpting at all. If I have basic sculpting, what I've done is I've had so many different videos for you, and it's getting old and repetitive, and you can criticize me for all sorts of things, including the fact that you think I charge too much money for my classes. Oh shit, what am I supposed to do? I want my classes to work more than anything else. If you think I'm charging too much for my classes, send me a email and I'll give you a scholarship and I'll make sure you can afford it. I just want people to take the classes, nothing else. So what I do for normal situations is you first figure out the debt service from our DSCR formula. See, DSCR cash flow divided by debt service. Then you reverse the thing around. You do some of your fancy algebra and figure out the debt service is cash flow divided by DSCR. Ah. Then you can say the NPV of the debt service is the debt at the COD. That's the key thing. So you size the debt with the uh, 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 sculpting from the debt service. You size the debt from the debt service, and then you split it out and everything else. But what happens if up here, now I've got to find this, what happens if instead of this, we say we'll start with our project cost, and then we say, well, debt is a percent of the project cost. Now, if we do that, and then we want to do our sculpting, well, what we could do is do the same thing. We could use our formula and say debt service is CFADS divided by debt service, but this will not work anymore. These will. So what we do here is then we figure out we need to adjust, need to adjust debt service. Now there are, in order to adjust, I'm going to go over here and shoot, yeah, let's do this, because at the end of the day we're going to go through some exercises, and maybe it's really silly for me to do this. We're going to go through some exercises, and we're going to um, compute the equity in the debt IRR. I've got to plug in my fan for my old computer here. Oh, shit. Okay, now, the first method that I always used to use, method one, so what happens, and I'm not explaining this clearly enough, you're never going to take my class. The point is, you need to adjust the debt service because oh shit, what happened? My computer is out of batteries now. I'm not going completely senile. I'm telling you, I'm not going completely half senile because of this pandemic. I am going a little bit crazy, so that's not true, but I hope it's not completely senile. Need to adjust the debt service because PV of debt service does not equal debt. And that the debt from project cost. Okay, enough of that. I'm running into my graph. I better stop. So method one is what will happen is there'll be a constraint. It will always be the fact. I'm gonna have to let's put some more things up here. It will always be the fact that the debt will all debt service from sculpting formula will always be less than the 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 debt the debt service to meet required debt. The required debt. That's okay. So here the if the DSCR, if you compute this minimum DSCR, and if it produces a value of debt that's less than the required debt from the project cost, I'm gonna have to prove this with Excel. Then, if it's less than that, then that's the amount of debt you choose. So the debt here, maybe I'll do it here. Debt from project cost is less than or equal to let's put the PV of debt service from sculpting. Now, there are four methods at least that I can think of to deal with this. Method one is sculpt with DSCR and stop when the closing balance goes to zero. And what happens to that one is, so what we'll do is we'll sculpt the debt, and suddenly I'm looking at this graph. Suddenly it will stop. Okay. Method two is we sculpt with LLCR, which is going to be higher than the DSCR, and go to maturity. Method three, I should change this to method two. Method three is going to be method three is we'll have a curved DSCR with higher than min in early years. And then method four, oh no, I'm gonna, maybe I can move these over here, huh? Uh-oh, uh-oh. Okay, method four is a fancier thing, is curved DSCR to meet minimum with higher than min and meet average debt life constraint. Okay, so I never realized after wasting my time in one way or another doing all these different methods that what we really need to do is put these different methods together and compare these methods and see what kind of different IRR you get when you sculpt this. And I have never been able to explain it. and never been able to do it. Of course, Hetty told me how to do everything. And what we're doing is we're making, this is so cool. I just can't believe how cool it is. We're making it so you can put different debt services in, and we're making this UDF parallel model. We're putting all this kind of stuff in the UDF parallel model. And I can tell you this UDF parallel model, if you don't have any idea what it is, don't worry about it. But it's going to do it automatically for you. And you just press a button and it gives you method 1, 2, 3, 4, blah, done. Put it as fixed repayment. You don't have to bother to do a whole bunch of circular references and all that. For me, that's a really important kind of thing to do. Okay, so let's work through this. So now to set this up, and I better, I'm gonna start putting the inputs here. So this one, and this is another thing, this fixed debt flag. God, I hate it. I'm never gonna do it again. This is when you sculpt. If you sculpt and you have some cash flow you're using for sculpting, and the cash flow that you're using for the model is different than the cash flow you're using for the sculpting. How should you do that? Because you have to recompute the whole model basically to compute the taxes that you would have if you sculpted, and then you compute the actual taxes. Let's shit can this one, because I can do it with the UDF so much better. And right now we'll start with a fixed interest rate. Now what I'm going to also do, and I might have to do this in a second video, is a much more interesting question. What happens if instead of one issue you have multiple debt issues? And what I'm doing is I'm working through this on a video, because I'm not getting paid for this and nobody takes my classes and everything else. I'm whining like a president. Let's put a growth rate of 3%. So I tried to get fancy and do this with a Monte Carlo simulation. So I put this kind of volatility function in here, which is so easy to do. It's incredible. But what we're going to do is put 1 plus the growth rate, and we put that in there. Okay, oops, and then it stops here because I did that. Stops here again. Oh, shit. Now it won't stop anymore. And so we have this very, very high project IRR of this. Let's put, maybe 1,000 in for our cost, maybe 1,400. That's too little, 1,200. Let's put an interest rate of 3% and try to boost up our project IRR. So these are our cash flows. Control C, and let's do this. See what kind of stuff I get. So those are some of our inputs. Okay. And I'm putting no volatility in, so I'm turning off the Monte Carlo simulation. And maybe later I might put in a 10% volatility, and we can see how it works. And then if you press it. Okay, I can't believe this. I am crying because I did this whole thing and then turned the record button off. So I'm going to leave some of the stuff I did. I just made a little whatever drop down box here, okay, with our 4 different methods. And what we're going to do is we're going to see what happens to the IRR. Now, right now, there's no debt repayment, so this IRR isn't correct. Okay, this has only got interest in it. So what we're going to do is we're going to, I'm going to go up here, and I'm going to make each of the methods. Method 1, we're going to figure out what the target debt service is, put a minimum in, somebody else. Okay, thank you. And then we're going to move to method 2. Method 1, we'll just stop it somewhere here. Method 2, we're going to compute an alternative a DSCR. Method 3, we're going to make a basic curve DSCR and show you basically how easy this is to do if you use the interpolate function. Okay, and I needed to put well, maybe I'll make that a goal seek again. We need to, and then we're going to make method 4, which I didn't finish and I stopped. And then we're going to compare them all and look at the project IRR, equity IRR, and perhaps might even look at the average debt life. Okay. Okay. All right. And then so we have a target amount of debt of 650. That's the maximum they're going to allow us. And I put a nice low DSCR in here. And we put our operating cash flow. And I think I stopped the video. I hope I did this before. We got an 8.27% project IRR, a high IRR relative to the interest rate. And this whole thing goes out for 15 years, and we make the debt life equal to our project life. I didn't say that in the last one, so maybe I'll make a tiny little bit of improvement. So the first thing I'm going to do is go and do our standard kind of sculpting, where all we do is we take the cash flow divided by our minimum DSCR and do that. Okay, nothing special. That's this formula up here. Okay, and then we put equal NPV at the interest rate. Now I'm going to belabor this a lot, but that interest rate could be curved interest rate. It could be curved, and we take that and take the target DSCR, and we get an amount of debt that's about twice as big as the maximum debt. Oh no. Okay, and then so that's our target debt service, and then I'm going to put our repayment. And every time we do the repayment, we remember that debt service, I didn't put this, is equal to interest plus principal. So we take our total debt service, and then down at the bottom kind of here, I have a little opening balance and a closing balance. And the interest is on the opening balance, always on the opening balance. If you try to do something fancy and make it on the average balance, it would be an ultimate waste of time and inconsistent with you doing your models with a quarterly or semi-annual basis anyway. That's our repayment. Now we go down, and then I'm going to put our repayment applied. So what I did is I took this number. So this is just our little code number from our little drop-down box. So if we use method 1, we've got method 1. And then I put a choose command, and we choose this one. I hate to do this. I feel like such an idiot doing the whole thing over again. And we choose that one first. And then later we'll choose the other ones. Oops, and I forgot to press the F4 key here. Probably because I'm all pissed at myself. And then we put our repayment here applied. And then when we put our repayment applied, oh, that's pretty cool. It goes up here. But then, the debt goes negative. The debt goes negative. So kind of Project Finance 101, put a minimum on your scheduled debt repayment and don't pay more than the opening balance. If you have a sweep or something like this, you get that. So now our IRR is 11.71. I suppose down here, and then our debt service is here, and I computed our DSCR, and it gets really high in the last one, and I can put our, how about let's put sum of opening, I think you use opening balance, and let's put equal to sum up here of all of the opening balance of the debt, and then starting debt, how about debt at COD, we'd need a little lookup to get that. And that I'm just going to put that as our target amount of debt. And then we can get our average debt life. And our average debt life is just this divided by this. So it's only 4.85. Well, okay. Now, that's what I used to do ages ago. The very first time I ran into this problem, I thought, oh, that's all you do and it's fixed. What an idiot I was. And then I thought, no, let's get a lot cuter here. Let's understand that with sculpting and a constant DSCR, if it's a regular old sculpting, LLCR equals DSCR. So instead of using the DSCR, we can use the LLCR in our sculpting. Now to get the LLCR, LLCR is NPV of CFADS. So we put NPV and we use our interest rate. And remember, blah, 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 blah. I'm repeating it so many times. We can use our interest rate that's not constant. Okay, don't freak out and say, oh, it only works with constant. That's crap. And then the amount of debt we have is up here. We said, okay, we only have 650 debt. And then we put our LLCR as this divided by this, 2.24. And then I'm going to use this for the sculpting, and I'm going to take our cash flow and divide it by this, just like we did before. No different. And then our repayment is this number minus this. Now, I've gone through this other times, and incorrectly I've suggested this is some kind of good method, and I was full of crap. So this is our repayment method 2. And I subtracted it from the debt, right? Okay, and then we go down, and in the repayment applied in our choose command, then let's throw this second method in there. Okay, very good. So far, so good. And if we put the method 2, we get a lower DSCR, and it goes across. Now look what happened. Method 1, 11.714. Method 2, 16.249. A longer debt life and a higher IRR. That seems to happen a lot. Now, before I say this, if you would assume refinancing here, everything changes. And you probably should assume refinancing here. So perhaps this method that I think is so much better is kind of an idiot method. The only good news is we get to pay more dividends here. So we could also assume refinancing here and say, okay, I'm gonna pay back this debt and I want more debt, and forget about that debt to capital constraint. Okay, refinancing really does change absolutely everything. It should change the way you think. And now I'm not putting refinancing here, and because what we'll do first is put multiple debt issues in. All right, and then what I did is if we make this one method 2, I just said, okay, let's use XLOOKUP, and let's find year 15. This is when we want the whole debt to be paid back. And then let's put this whole row in, and then let's go and put the where in the hell is the debt balance? There, put the closing balance and make sure that closing balance goes to 0. You can use XLOOKUP just like regular lookup, but then you can do all that other nice stuff. You can put a match model in and all that stuff, so it's much, much better. Okay, that's the XLOOKUP, whatever, that's the closing balance. And now let's put a little test. Let's make sure, let's go down and get our, let's make sure that we don't kind of violate this closing balance test somewhere. Where's my closing balance test. Check of closing balance right here. And let's round it and make sure it equals 0. Okay? Point number 1 finished. Now, let's say, here's what we do now, is on the next, for our next exercise, we go through and we're going to make this DSCR really, really low and this DSCR really, really high. Maybe it'll be negative. I don't care if it's negative. And then I don't care about that. And then what will happen is our debt life will be longer. Maybe we can push the IRR up above this, and we can get, maybe we'll hit our DSCR here. What we want to do is allow more dividends in the early year and less in the later year. Okay, so I'm going to put 1, and then I'm going to put our 15 up here. And that's our curved sculpting. And the reason I'm doing that is and then let's put our minimum DSCR up here. Okay. And but we don't know what our first year is. Now, if you set up a table like this, it's my interpolate lookup. I can't believe Excel doesn't have this. I cannot believe it. I'm going to put 3 here. I'm going to start with 3. And what you can do now is I'm going to put 3 curved DSCRs here. How's that? I'm going to put a linear interpolate. Oh, let's put it down here. And let's put a true. And let's put curved DSCR linear. And then let's put curved DSCR growth. So there are different ways. Whoops, I don't want the airline model. Growth. So there are different ways we can compute this. Now, the way you use the interpolate, there are other videos on that, so I'm not going to bother. If we put interpolate lookup linear, we go up to this number up here, and then we click on our little matrix for when we start, and we click on this is just regular old lookup stuff, and then it goes from 3, and it gradually goes down to 1.2. And then we'll do the same thing, equal interpolate. Now I had to copy this into the file. So if you don't know how to use this, look up a video. I wish you'd take one of my classes, spend all these ages marketing, and this one is a little bit higher, and then it goes down a little bit. And if we could even, let's insert a little spark line here for this, and put it over here. Okay, so that's our, can I control down? Yes, I don't know, they look a little different, I guess. And then let's put applied, curved, DSCR applied, and put an equal to the true, and we put if. Now, if you don't want to do this, fine. But if you want to really be a pro at modeling like Hetty is, then you want to do this kind of stuff. And then we can, I suppose, let's waste a little time with this little gimmick and put a thingamajig here, you know, and whatever. This is going to be linear. Excel would fix the damn thing, so I could not have to do it in a blind way, assholes. Okay, and then we put it over here. And then we click on this one, so we can either do one or the other. Now, once we do the linear, then we get, just like we do every other time, let's put let's put up here, let's put our cash flow in here again, just so we can really see it. Perhaps it's better. And then, so for the umpteenth time, I put my cash flow. And then my debt service is this divided by the DSCR. And then we put our NPV at the interest rate, of course, and you'll use the sum product when you do it, in a refined way. You use the NPV of blah, 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 this debt service right here. And you get more than the target debt service. We got too much. So what we're going to have to do is then, we don't have to do anything. Yes, you do. You have to eat, maybe, or what you have to do. And then we take the difference. Now, since I did it already, I already have a range name here. No, I don't. No, I don't. Shit. Let's move this over here, and then let's Shift Control F3. And yes, I'm going to replace it. Okay, and then we also wanted to do the same thing up here. This is our first year DSCR. Now, what we're going to do is we're going to blah, 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 blah. Sorry, I think we better put our little David Lee top on the top. Yeah, we need that, don't we? Maybe. Okay, and then we, God, okay. This one's an input. The reason I did that coloring, I wanted to make this an input. So we're going to do a goal seek. We're going to find this number, and right now we have too much debt. And if we have too much debt, we're going to have to increase that DSCR. And if we increase the DSCR at the beginning, I think we'll pay less. So what we're going to do, I made a macro. That just does a goal seek. So it makes a goal seek, set this number to 0 by changing that one, and I put that. So right now, it's got a really high upfront DSCR. And if we click on the third, no, we're not finished. No, we're not finished. So our repayment is now whatever method we selected up here for the debt service minus the interest. And this might be, it's just, is it positive? Just positive. You got a really low repayment at the beginning. Okay. And then when we put our repayment applied, now let's put in our third method. And our third method is up here. Okay, and then, oops, I don't know why it gave me a gray number, but whatever. Oh, I must have put a sum function in there. That's okay. I think that's okay. So now let's change it to method 3. And this is kind of good. The closing balance test worked, and we get a really low payment at the beginning and a high payment at the end. The only problem is our average debt life. Our average debt life was a little bit higher. Okay. Now, what we could do this time is we could. So this time this kind of sucks, doesn't it? Let's do this. Let's move this one down here, and let's move these ones up here. How's that? And I don't really care where this thing is, do I? Okay, so if I put now my, we get to 20% IRR. This one was only 11% IRR. This was 16% IRR. And this was 20% IRR, but we didn't address that we could have a debt life constraint. Now, let's say that the bank was really nice and gave us a 15-year debt life constraint, or the debt was bad and gave us a 10-year average debt life constraint. So we need to put up here our debt life constraint. Now this is going to be a little bit trickier. And remember, yeah, this one, and I'm going to say it's 10 years. Shift Control 1. Okay. And what we do now is we basically, let's go through the same thing. By the way, if I did it linear, then of course now we get a CB of false. If we do it linear and then press our little button for our curved DSCR, we get 19% IRR. If I do it with our curved sculpting, then we get 20%. So it makes a little bit of a difference. This is our, let's call this curved sculpting. Okay, now part of the reason I'm doing this is so I can incorporate this whole thing in our UDF. So you'll never have to press a button and it'll just give you the result. Now, but let's do the last method. And the last method, because we could put all kind of shapes in here. We could have kept it low here and then pushed it up. We could have pushed it up here and then, we could have, that's what sculpting and art is all about. Not art, it's not art, it's not art. Stupid. So the first thing is let's put all of our stuff here. I better put a little more space down here. Maybe I'll make it a little smaller. Okay, I hope you can. Well, whatever. I'll be okay. I've just got to see that, and let's put our. We're gonna do the same sort of thing. I'm gonna copy the titles here. Okay, and then perhaps before. Oh shoot, that was idiotic. Let's do it like this. Why don't I do it like this, where I copy the whole lines and I press Shift Control Plus. Does that work? If you have a UK keyboard or whatever, a different one, you might have to just press Control Plus. And what's this blue number here? Well, that's just our little spark line. Okay. All right. And then maybe I should have left it. But then we'll also put let's put a resulting average debt life, and below and then we put target debt life, and then we put a difference. Now, when you have this, you could use the solver to do two different goal seeks. Okay, but you could also try putting two goal seeks in, blah, 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 blah. Maybe we'll do both of them. What the heck? Am I still recording? Yes. Okay, so let's start with this one. And so now we'll put our minimum DSCR here. And let's put 4 here, something else. And I think I can still use this button, but I better blah, 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 blah. Where's the, oh shit. This is here. Okay, good. All right. Okay, and then we put our interpolate in. And this is interpolate linear. Why not? It's good to do it twice. That's a user-defined UDF, a user-defined function. Okay, and then this, oh shit. And I can't, damn. Okay, so I put my interpolate here. Let's do the regular interpolate without the linear. Okay, again, I got a little bit flustered. You put the first thing in, you put this thing in, and you put that thing in, and then you go. Excel hasn't put that in yet. We don't care, and then we put an if statement in so we can make it linear or no. Does that work? Of course, this if this should be this one maybe. Okay. So we can make it linear or the other way. And now we put our cash flow in just like before. Whoops, our cash flow is wrong. Our cash flow should be the famous 100. I took it probably from a bad line. And then we put our debt service as this divided by our applied one. And then we put our NPV. Let's put our NPV and make sure we use the right discount rate. I should have locked it with an F4, of course. And we'll put this of the debt service. And then we get our target debt. So I'm doing it again, but I don't think it's that bad. And now we get a difference. And I'm going to call this method for difference. And we'll call this first DSCR4 or something. And then we're going to do a goal seek on that. But before we do a goal seek on this, okay, let's switch it. Let's put our repayment from method 4 as always our debt service minus our interest. And you know, can I just tell you something else as if you give a crap? If you use a template model and have this stupid belief that your template model is so good and you reuse it over and over and over again, instead of just saying, fuck, screw it, I'm just going to make a new one. Okay, and then okay, and then I'm going to okay, what am I gonna do? Okay, I'm old. I lose my train of thought all the time. I'm not. I hope I'm not completely senile. Okay, so then we got our repayment applied, and in our this one we better put our repayment for method 4. Okay, this one was this minus the debt service. Good. Oh God, did I lose my train of thought just now? Okay, because it's hard making these videos. And what happened here is that the closing balance did not go down to 0. Don't worry, but that's because we didn't do the goal seek. And then we have also, we have the debt life of 11.4 this time. If we made it, I hope it would be different. If we made it 3, it would be 11.59. But what we wanted to do, so I'm going to leave it on this method 4, and I'm going to put the resulting debt life here. Okay, and then I'm going to try something, and I don't know if it's going to work. I'm going to put my target debt life in. Now I'm going to first do something by hand. Okay, the first thing and then I'm going to take the difference. Oh, the target debt life, not the target amount of debt. Okay, and then I'm going to do this. Now, if you notice, there are really only a couple of things I can play with on this. I'm going to have to temporarily hide this. Let's take all that. Oops, why did that not work? Okay, I don't know why. I'm gonna let's temporarily hide this stuff up here. Okay, and then once we have that, now let's look at what we could do. So right now I've got too much, I'm paying too much debt. So if we put 4.5 here, it didn't work. It went, let's put 3.8. Then we pay. So we could do a goal seek to put 3.85 or something. And then we're getting closer here. But we could also have this difference. And to get this difference, I could, if I put up here 16, and how about 20? Whoops, or 14. Yes, 13. Then what's happening is it's giving us a different debt life. Now, if I put 100 here, okay, so let me make this. See, I told you I was kind of experimenting, and I might cut this part of the video out. Just hang on. So what I did now is I made I've got some background noise from some idiots here. So God damn it. I've got and then it's hard to maintain my train of thought. So I made a macro, and I made a macro that just makes this go to 0, so nothing. Now I'm going to make another macro and make this the average life difference. So we have to remember this name. Shift Control F3. Whoops, I did it wrong. Okay. Why didn't that work this time? Okay, so we'll name this one, and then we're going to also name this up here last year. So we'll make a second goal seek. Okay. And remember, average life difference and last YR. Average life difference, last YR. Average life difference, last YR. Average life difference. Let's see if I can remember this. Doesn't really matter if this was difference and last YR. Okay. And of course, after I said it so much, I still got it wrong because I should have said AVG. Okay, back to the video after a pause. What I just showed you was complete bullshit. Okay, it didn't work. So I tried something else. Because I couldn't get the two goal seeks to work, and I put them in a double stupid loop, and it didn't work, and all that. And I've tried that before, so it's really embarrassing. Now, if we have this, let me tell you, kind of my solution. We have this big square matrix, okay? And actually, maybe I've never done this before. Let's do that one. Let's put something here. Let's put, we have last year and first year. Now, the first year will always be 1. Okay. And so we'll select that one. All right, and now it happens that I have every single thing as a ranged name around there. I've never kind of tried that before, but that's what we're going to do. And then to show you how this works, I'm going to put reset. Now, what must happen in these videos when they get so boring, and this is why you have to take a class, please. I'm having a class basically just on this sculpting business, and then you know what you do in the real model is you put a cash flow for sculpting and a separate cash flow for your analysis. Okay, and That's crucial. And then in your little input, you're going to put a fixed DSCR. And when you do all of that, you can use all my parallel model stuff to figure out, we don't have to make the model 4 different times for 4 different P50s or P90s and all that stuff. So back to where I was. Now, if I press reset, what it does is it just puts 5 in here and puts the last life. And then I run that. This time I'm just doing it only with and this DSCR, this second DSCR. What is that supposed to be? That should have been the DSCR range DSCR first DSCR. Range DSCR2, which of course I named it differently, and now finally I'm not so stupid that I don't even show the window in Excel, and let's put that as just the minimum DSCR. Oh God, I wanted to be finished with this stupid video already. Let's make that one a range name. Okay. All right. Come on. Yeah. All right. So we're going to make a little reset button. Maybe I should be emphasizing these reset buttons a lot more. And I can even remember this because I just woke up and I'm all worried about this politics and all this shit. Okay. So when we reset it, we'll do that. All right. That's our first one. And then we got a debt life. We got a debt life that was too long, and we had it set to 4. So one of the things I could try to start doing is try to start putting in like something like 14. If you put 14, oh no, the debt life, and then 13, then the debt life 12, is the debt life getting bigger? The debt life's getting bigger. That doesn't help. So if I want to make the debt life smaller, what I can do is never hit the DSCR. So if I put 1.5 here instead of 1.2, then it's getting there, 1.6. So what we're doing is we're dealing with the whole square. Oh, we're getting there, 1.7. Now I never ever reach my minimum, so it's kind of like, I don't like it so much, 1.8. And we'd have to negotiate with the banks and all that. That kind of worked, 1.75. So we could come up with combinations to do this. Now I could put this shorter and this longer, and then I have a different pattern that's close enough. But instead of doing it like this, you could make a two-way data table where you change both these two things, this one and this one. And so I made this two-way data table. Now, when you make this, excuse me, this is the ending DSCR, I hope, and this is the end life factor, and this stupid thing up here is nothing. So what I do is I make this big data table, and I wasted tons of time on it because I thought, I'm going to show all you how to do this, and then of course I stopped and I said, all we have to do is make a output range and find out where the start row and how many rows there are and how many columns there are, and work through the whole thing. And I made about 20 errors. It took a hell of a lot longer than it should have. But down here, this is the average life table. Now instead of doing it like this, I do it in a program because it's a pain for you to do. I can imagine if you've got a really big, long model that you don't want to stick this in a page somewhere and then have to figure out what combination. Let's find this combination that kind of worked. So we had a combination. Watch me have done it wrong, and I might have to pause the video. I'm just warning, and I'll probably swear then. But I've sworn anyway a lot, so that doesn't really matter too much. 15 years, 1.75. Do I have 15 years here? 15 years. Oh, shit. Oh, shit. Okay, just a minute. Damn, I'm going to end this video. Okay, just like you're wasting time with this, watching this video, I wasted time by making this stupid data table that's too long. But I did discover sometimes when you screw up, I give you idiotic philosophies sometimes, but when you screw up, that can be the best thing. Because that what you can do, if you change this little range name called output, I hope I changed it. We can check. Okay, I press Control F3 to change it. Shift Control F3, makes the names. Control F3 makes you find it. And then I made this this horrible macro, but it really actually is not that horrible. You have to remember, you have to take this output, find how many rows you have, the start row, just like I told you, blah, blah, blah. Then you stick in the last row from as you go through the rows, that's on the column. You stick in the second DSCR, you make your goal seek, and then you plop it in the output. And you can put a little status bar if you want to show where you are. Okay, that's it. And then that status bar, I didn't press false, so it kind of leaves you there. But what we do then is I had some little thing. So now it's going through and it's computing the average life for each. Let's do this again because I'm kind of happy. You know what happens if you put the average life in too long? Some kind of goal seek just goes crazy. So you just put this in. And then we can kind of see, there it is. It's like somewhere here. So if we put, what if we put 15.5? That's not 1.5. That'll screw it up. 15.5, okay? Let's see that. And I'm looking for that one. All right. So if you're going to do this, okay, it worked through it. You know what I should do is I should clear the output. Let's do this one more time. And I'm going to put this obviously on the website, but I'm going to, I have this whole section on making these goal seeks with data tables with the goal seeks. Okay. One more time. So we got it. Let's put, this was a little too much. How about 15.25 and then 15.5 here? Let's see what happens there. So we're getting closer. I should have got rid of that thing. And then, when I cleared it, suppose it clears the formatting. So we're getting close. That's close enough. Now, what I did, this is kind of a pain. Like I said, if you ever really have to do this in your model, it's kind of a pain. But let's see if we can remember where we are. So when I do this, now I can say, no. Let's put in 1.75 and 15.5 in our little square. Did I say 15.75? 15.25. 15.25, 1.75. 15.25. And let's see what happens when we do our little thing. And the last year should have been not 1.8. It should have been 1.75. So isn't that a pain, by the way? So in that UDF, we try, Eddie and I, try to make this all automatic for you. So when we do this now, because of our debt life constraint, we're down to 10, we're down to 17.4. And let's review. If we did it this way and had no debt life constraint, we'd be up to 20. If we did it this way and just did a flat IRR, we'd be at 16. If we cut it off, we'd be at 11. My God, this makes a big difference. And I didn't fudge it, and then we could do all the sensitivity analysis with different ending DSCRs and all this, and you know how to negotiate. That's why you're making a model apart, whether you're the bank or the other part. You want to negotiate and see how important it is to negotiate the average loan life or the the minimum DSCR or the debt to capital, and I can't even. Now my brain is fried, totally fried right now. Which one would be better? You'd have to do some scenarios, and that's really, I'm selling this UDF. This is all automatic in the UDF. You just stick in an average loan life. You stick in a minimum DSCR. You stick in a debt to capital. You're going to make your data tables to God's whatever. Okay, now the other thing that I haven't done yet, and that's almost why I made this, all I'm going to do right now is press Alt E M, and I'm going to go to this little thing. So what I did in this little model of this little thing, I put all of our little examples here. Okay, and let's create a copy and put it before this sheet. And this time, we're going to take this same one with fixed debt and multiple issues. Oh, we can't do that. Sculpt. How about sculpt, fixed debt, multiple issues. And if you don't think how about mult issues? And I've obviously gone on too long, and I'm trying to use this to make sure that our UDF system, where we can just have you, it's going to be so cool. I swear. You've got to use it. You've got to try this, please. We're going to have a little parallel model, and all you do is you put this in, it right there. It copies it all for you. It copies all the code for you. It does kind of everything. And copies the sheets to your sheet, and then it does a little format. And when you finish this, all you've got to do is put one of these things. You can get all these different reports. They're standard reports. You can change them. That's the biggest deal. You can change them. You can change them. You can put you can match it exactly to your format if you like, unless you've got a really crappy format, which a lot of people do. And then we have this thing right here, curve sculpting flag. Maybe that's a horrible name, but we can, over here, we can put, 1 is the minimum, 2 is flat LLCR, I'll call it. 3 is curved without constraint, and 4 is curved with average constraint. Now here, CONST. And if I can make this, so you can just, oops, that's not what I wanted to do. If I can make this, so you just collect a few little pieces of data from your model, like the capex, like the interest rates, like the commitment fees, some development costs, and some other stuff here, all this red stuff, your debt to capital, if you want to put fixed debt in, you can, your minimum DSCRs, a few inputs, not a lot of, goddamn it, not a lot of inputs. If you can put a few of those in, you'll run the model, and the model will give you the debt the repayment percent, and it won't only give it for one issue, it'll give it for multiple issues, and that's like your fixed pasted. And then when you go to your input page, and I should have done this really, you go to your input page, and I think this was kind of a simplistic one, but we should really separate the operating inputs from the financing inputs. Maybe I have to do that. But in your input page, when you go down to the debt repayment amortization period, up here we could put fixed repayment. And then you could put dynamic repayment. That's what Hetty does. And she also puts annuity repayment. Okay, and you can even put the old-fashioned equal installment. Now, the big deal here is that the dynamic repayment, dynamic sculpted in Excel model. Now, this fixed repayment comes from the UDF. Now, if the UDF computes it and it's fixed, it's there. It's like a fixed number. And if it produces the right DSCR, the right debt repayment, the right average debt life, you don't have to bother with all this. Oh, let's check it. Let's put it 5 different times in our model. Let's just put it there and let's just use something like the P90, P50 to get all of that. And that's an enormous painful thing in a normal Excel model to do. And that's the real advantage of the UDF. You know, so one of the advantages, okay, when you go to the summary page, you don't have to click the stupid little model optimization button all that time, okay, but that's not that bad really, okay, I have to admit, as long as you do it efficiently, that doing this little model optimization isn't that bad, and even doing this fixed debt for me is a little bit of a pain. But all of that stuff you don't have to do, and you don't have to you still press the reset button, I guess. But all of that, running the sculpting, putting P90 in, putting a whole separate page for P90, P50, running the taxes for P50, P90, you don't have to do that. I hope you've turned this video off by now. I've blabbered enough. Okay.